Next week, right? CBT. But which CBT? I've been, I went round and round to college and I've just been too far forward myself. And it's from Canada. Let's roll it. I'm and then we went in and I saw that. Yeah, you should get. I'll probably fill away. I'm gonna see.
Good afternoon. Okay, let's do this for one last time. Okay. Last lecture, next lecture is exam. So gladly we are here. Today I want to talk about mock exam 2 or essentially discuss it. Ask or address any questions you may have about how to prepare for the exam, how to complete your project and essentially complete this course. Okay. So as I mentioned before, just like exam 1, exam 2 will also have 5 problems. I hope at this point you have seen the mock exam already and started working on it. You are required to upload a handwritten solution to this exam by midnight on Saturday for 3 points, just so that I get you to do this at least once. Please do that. Don't miss out on those 3 points. I don't think after this session, I don't think I need to post the solutions because today is the solution. All I'm asking you to is to do the work and get credit for it.
You might have answered this before, but handwritten, do you use pencil or can we do it digitally as long as it's still in our handwriting?
Digitally is okay, but don't upload an Excel file. I want to see the calculations. Ideally you should not use Excel. Ideally you should do this with only like how you do it in Excel.
Yeah,
That's fine. Okay, so as in the first exam, the final answer only carries a small portion of the credit. The steps carry most of the credit. So please write all the steps clearly. That is easy for us to read and grade. If you don't give us the steps, we would have to assume that you are just guessing the numbers and we will not give you points. I hope that is clear. Okay. For the exam, you can bring handwritten notes. People ask me how many sheets, as though that really matters. But since we have 4 modules that we are covering in this exam, I'll allow you to bring up to 4 sheets. Okay, I'll put this in the email tonight. You can bring up to 4 sheets, double side, handwritten, or written on a tablet and printed out. Okay. You should bring your calculator definitely, but no other devices or printed materials will be permitted. The 5 problems will have one on each topic. The first problem is going to be based on Gauss-Seidel. Second problem is going to be based on curve fitting. Third on numerical integration. Fourth on numerical differentiation. And the last problem on solving a ODE, which we'll see as a template today. Any question at this point? So without further delay, let's just start working on these. I'm not planning to teach them from scratch, but we'll just do it together. And you can basically start writing that on a sheet and essentially turn it in. That's it. Can you make a note of this question so that I can turn off the monitor and we can work this out? 6x minus y minus z equal to 3. 6x plus 9y plus z equal to 40. And minus 3x plus y plus 12z equal to 50. 50. So what we are asked is to solve for x, y, and z until the percentage relative error falls below 3%. So ER has to go below 3%. Okay. it's not clearly said relative error in which number, X, Y, or Z. The conservative thing to do is to monitor the relative error on each of these and do this until all of them fall below 3. Okay. Either it might be asked this way, or it might just ask you to do 4 iterations. That's it. Okay. So how you would set it up is, let's say we call it iteration number, not that it matters. X, Y, Z, and then you can have relative error in X, relative error in Y, and relative error in Z. And relative error itself would be defined as absolute value of 1 minus X in the current iteration divided by X in the previous iteration. So we'll start with guess values. We'll start with, let's say we guess 0 for everything. Okay. The second iteration would be, so take these 3 equations, invert them or invert each to solve for X, Y, and Z. Invert each to solve for X, Y, and Z. I didn't talk about diagonally dominant during the lecture. So the way I present this in the exam, what you do is use the first equation to solve for X, use the second equation to solve for Y, and use the third equation to solve for Z. There is a little bit of nuance there, which we didn't discuss during lecture, so I don't expect you to know that. The thing is, the coefficient of X should be dominant than the other 2 coefficients. That is, the condition mathematically is A11 should be greater than or equal to A12 plus A13. This is called diagonal dominance. We didn't see that, so you don't have to know that. So what you do is take the first equation, invert it to solve for X. So X would be 3 minus or 3 plus Y plus Z divided by 6. And Y would be, inverting the second equation, 40 minus 6x minus Z divided by 9. And Z would be 50 plus 3x minus Y divided by 12. As you can see, this is 1 by 2 plus 1 by 6x plus 1 by 6y equal to 40 divided by 9 minus 2 by 3 x minus 1 by 9 z and 25 divided by 6 plus 1 by 4 x minus 1 by 12 y. Why this diagonal dominance matters is these coefficients need to be less than 1 so that the values of x, y, and z will converge to something, will converge. Again, you don't need to know this. Only thing is, make sure you use the first equation to invert for x, second equation to invert for y, and third equation to invert for z. Yes. The way I give it will be diagonally dominant. Just make sure you take the first equation for the first variable, second equation for the second variable, third equation for the third variable. If you switch that, you will never get convergence. Z. So once you have these three equations set up, which of course you can expect to carry a significant chunk of the credit, like let's say 1/3 of this is just to set up these three equations correctly. Then you start iterating. So if I want to update X, if I choose my guess values, okay, always use the latest value of X, Y, or Z for computation. So if I'm starting with X, I'm never going to use this X value. I'm going to use this Y and this Z. So that will give me 1/2 or 0.5 as the first value of X. Okay. Then when I want to do Y calculation, so this is iteration 2, X equal to 0.5, Y equal to, I have 40 divided by 9 minus 2/3 times 1/2, and Z is still 0. That is, I would use this value of X and this value of Z to compute Y. So minus 2/3 minus 1/9 times 0. So that will get me, can somebody tell me this? Should I use my own Excel? Yes. 4.11, thank you. 4.1111. So Y value is 4.1111. Maintain 4 decimal points in all intermediate steps.
For something like X is just 1/2, and it spits us that fraction. If we write it as 1/2, is that okay?
That's fine. It's an exact number. It has infinite resolution. If you can write 1/2 and then seamlessly switch over to decimal representation, that actually tells me you understand precision. So Z, to compute Z, you would use the latest available values of X and Y. That will be 25 divided by 6 plus 1/4 of 1/2 minus 1/12 of 4.1111, which should give us
3.9491.
9491.
3.94.
3.9491. So to compute Z, we would use this and this to compute Z, 3.9491. Yeah.
Exam, will you look for us to simplify these equations like that?
Nah.
Doesn't matter.
You do what you need to do to get to this number correctly. How you go in between, it's okay. I like fractions, that's why I hope. Okay, so for this step, you don't even have to calculate relative error because it's the previous values are 0. You would never have converged in just one iteration. So don't bother, don't waste time doing this here. Okay, and then next iteration, repeat this. So we'll do iter 3. X equals, you can just calculate this. I don't want to write it out. Calculate X based on Y equals 4.1111 and Z equals 3.9491. Good. 1.8434. I'll give a minute for everybody to get that. 1.8434. Getting? Good. Yes. So when I say relative error drops below 3%, you can add a sentence that explains your convergence criteria, and you could pick it for some weird reason. I'll stop as soon as any one of them hits 3%, but you need to tell us what you're doing. That is, I'm talking about the exam. You have to tell what you're doing. Yeah. You can make a choice, yes. But it has to be a sane choice. Yeah. Yes. X current step, X previous step. Okay, let's do Y. Y should, for calculating Y, you would use this latest value of X and the previously available value of Z, which should give you 2.7767. Good. And I'll just go ahead and write what I have for Z, 4.3961. Thank you. So now is a good time for you to check the relative error between the second and third iterations. So for iteration 3, relative error in X will be 1 minus the value at X3 divided by the value at X2. So that is 1 minus 1.8434 divided by 0.5. You can leave it as a fraction or a percentage. It's okay. Both are fine. And you do that, 2.67. Thank you. So you are getting 2.7. That is 2.7 times, or in other words, this is like 270% you multiply by 100. So the problem asks you to do until everything falls below 3%. If the first one of them gets you 270%, don't waste 30 extra seconds trying to compute these two. They are not needed. What is the main role of epsilon r? To make a decision to either continue or stop, right? If this is 270%, then the verdict is continue. Don't even try to do the next two things. You can do the fourth iteration. Maybe you can do this at home. I'll give you the numbers: 1.6955, 2.8257, 4.3551, and the relative errors come out to be 8.02%. Again, if I were you in the exam, I wouldn't do these two steps unnecessarily. But just for your reference, that's 1.76% and 0.93%. So do another iteration, and I know for sure that it will converge here. So make sure you show three numbers that all of which are below 3%, and you can just say that and stop. Okay. I mean, we will look for process, meaning we'll see how you explain or how you choose a stopping condition and whether the stopping condition is actually met, and then you stop. If you just stop arbitrarily, that's not the way to go. You should clearly say why you are stopping. Yeah.
Up there and explain it that way and get full points.
I don't understand. You are going to stop only based on y and not on the other two.
Yeah, that's what I was asking you earlier about.
So you are free to make any choice, and we are free to criticize your choice.
Well, I don't want you to criticize.
So you should make a reasonable choice. Meaning, if I say the relative error has to drop below 3%, what I'm implying is either each of them is below 3%, or if you do a root mean squared error, that is, if you define epsilon r itself as epsilon x squared plus epsilon y squared plus epsilon z squared, and if this drops below 3%, those are reasonable choices. But if you just pick y or z because z is already kind of converging, that is not a choice, and we will take points off because you made a poor choice.
Thanks.
Okay, pretty good. Any questions? Can we move on? I've spent about 20 minutes on problem 1. That is having the answer. So you guys have to do this without having the answer. Okay. So problem 2. Okay. I'll bring back the screen. Just making sure if the recording is on. Yep. Good. So for curve fitting, this is the template you're going to get. A table of data with x and y and a fit function that is given to you in terms of 3 trial functions with C1, C2, C3 as constants that you need to calculate. So you're not going to be asked a simple linear fit or a simple quadratic fit, telling you right now. It will be 3 functions that will be an exponent or sine or something, but no simple quadratic. Okay. In the file that I posted of this mark, I had made a copying error and these numbers were wrong, but now this is how this is corrected now. But this is the kind of data or question you're going to get. You will be provided all these summation values. You should know where to place them. That's the main skill. Once you place them, you will be able to generate 3 equations in 3 unknowns, and you have to solve for C1, C2, C3. So this is coming. Solving for 3 equations in 3 unknowns is coming. Only this time you can just use your calculator to solve for C1, C2, C3. You don't have to show the intermediate steps. Just tell us the next step. That's it. Make sense? Yes, Sandy.
We have to show how we solve the 3.
I just said you don't have to. Okay. I just said you don't have to. Just say this is the 3 equations, and next step C1 equal to C2 equal to C3 equal to. Bam. That's it. Okay. Shall we briefly recap this? Yes.
Basically, you don't show the steps, how you got the answer. I'm assuming you get 85% if your final answer is wrong for that question.
If your steps are correct. If steps are correct and your final answer alone is wrong, you can expect something like that. But it's hard to give any guarantees. It's very subjective. People always make some conceptual error. Okay. Shall I just go over this briefly? How to use these summations? So I'll leave that on so that. Oh wait. All this while screen share was on. So the camera gets a chance to capture this frame so that you guys can see it later. Okay, so now so you have your trial function or you have your fit function y equal to C1. What is the first one? C1 e power minus x plus C2
Cosine.
cosine 2x and C3 ln of 1 plus x. Okay, so need to use the data to solve for C1, C2, C3. We can get an equation from the data. You can write yi equal to C1 e power minus xi plus C2 cosine of 2xi plus C3 logarithm of 1 plus xi. Now this is true for this particular problem where I use exponent, cosine and ln. But if I just write this in a little more generic form, you can use it for any problem while you practice. Okay. So I'm going to write yi equal to C1 f of xi plus C2 g of xi plus C3 h of xi. This is valid, or this has to be, or this is supposed to be valid for each xi yi pair. So we sum over all n data points to get sigma yi equal to C1 sigma f of xi plus C2 sigma g of x plus C3 sigma h of xi. So this gets you one equation. So you would place the summations from the provided table, provided info over here. Yes. With me so far? This is all recap of what we have seen. Okay. So if this is true, for every xi pair, what I do is I multiply by xi and write xi yi equal to C1 xi f of xi plus C2 xi g of xi plus C3 xi h of xi. And then sum over n. I get sigma xi yi C1 sigma xi f of xi plus C2 xi g of xi that gives me a second equation. Again, these are provided, place them here. Yes.
For the first equation, the one right below it, that's like what the simplified version?
This one?
Yeah.
This is obtained by taking this relation at every data point. I am allowed to multiply throughout by xi. That's what I did here. And then I sum over all the data points. I get a equation which has linearly independent coefficients. Okay. You get to bring a cheat sheet, right? If I were you, I would put equation 1, 2, 3 on my sheet, knowing that something like this is coming. Yes.
Last time we did we do 2 cheat sheets last time?
I'm telling you, we can bring 4.
For sure.
There's still one more equation which you can obtain by multiplying this relation by x squared or xi squared to get one more linearly independent equation, and then you sum it over n. So you get sigma xi squared yi equal to C1 xi squared f of xi plus C2 xi squared g of xi plus C3 xi squared h of xi. So there's your third equation where you have to again place these coefficients that are provided to you. So you get three equations. So something like this. We'll call it alpha 1 C1 plus alpha 2 C2 plus alpha 3 C3 equal to alpha 4. Oh, sorry, equal to beta 1. 1, 3. So alpha 2 1 C1 plus alpha 2 2 C2 plus alpha 2 3 C3 equal to beta 2, and then alpha 3 1 C1 plus alpha 3 2 C2 plus 3 3 C3 equal to beta 3. Solve for C1 C2 C3. No need to provide any details, just put it in your calculator and provide the C1 C2 C3 values. Then you are done. Okay. This is the answer we are seeking. So I'll show you my Excel sheet so you can see what solution I got. You can generate your own problems, really. You can pick your own constants, you can pick your own functions, generate your own data, and then you create all these columns, create the sums, and then this is what you need. That is, we'll provide you these sums. You have to essentially set up these three equations and then solve for C1, C2, C3. I'll post the edited mock exam file when I get a chance. Are we good? Yes?
Do we have to worry about the log meeting? Like the power equation?
In life, yes. For the exam, no.
Okay.
Yes.
So I tried setting up a transverse matrix to solve for C1, C2, and C3 in my calculator. And it gives me a singular matrix error.
I'm not sure because I also used MATLAB to do the same and it gave me these numbers. Smith, did you do that with the updated coefficients?
Yeah, I just wrote down the coefficients. That here.
Okay, maybe something we can check offline because in the 45 minutes I do have, I want to finish the other 3 questions. Yeah. Okay. Yes.
In that formula that you're going for, how do we know which numbers to table you use? Okay.
Which numbers? What? Sorry.
How do we know what numbers? Like, how do we know what to plug in the formula? Like,
So you look at this. You have to remember which function is referred to as f of x, which is referred to as g and h, and you have to pick the correct sums. Because look at the question here. The question makes a specific reference about which, in fact, it doesn't talk about F, G, and H. It just directly gives you the summations. Again, this is where I'm saying if you have done this at least a few times, at least 5 or 6 times in practice, you will know what you're doing and it will not be hard at all. It's very straightforward. Okay. So just practice, you'll see it. Okay. Problem 3. So the one-dimensional velocity of a particle trapped along a line is found as time and then velocity as a function of time. Okay. Compute the position of the particle, compute the that doesn't sound right. Compute the position of the particle. Yeah, compute the position of the particle between 0.7 and 0.4, and then compute the distance traveled by the particle between 0.7 and 0.4. Okay. Yes. Correct. Part A is displacement, part B is distance. Okay. So we'll write it out. It still uses your numerical integration idea, except it asks you to think about what should be integrated. So V represents velocity with a sign, which means for a one-dimensional particle, V could be positive to the right and negative to the left. Okay. We are asked to calculate what is the distance traveled between t equals 0.7 to 1.4, which you can write as integral t equals 0.7 to 1.4 v dt, where v happens to be a number with a sign. So this would be, if we use our trapezoidal rule. What is trapezoidal rule? I equal to integral a to b f of x dx. This is equal to 1 by 2 delta x times f of a plus I equals 1 to n minus 1 f of xi plus f of b. This is the formula you need to know to apply trapezoidal rule. So this essentially comes down to half delta t first value plus intermediate plus 2 times intermediate values plus last value. So in our case, this will be half delta t velocity at 0.7 plus 2 times everything that comes in between plus velocity at 1.4. So if you look at the table, between 0.7 and 1.4, you have 6 values. So the distance between t equals or t2 minus t1 would be half. What's the resolution of our time? 0.1 seconds times f of a, that is the starting value is 6.5602 plus 2 times everything that's intermediate, 5.1581 plus 3.8176 5645 plus 1.4241 0.41 92 minus 0.43 4305 plus the last value minus 1.1098. So this is position, or actually this will be called displacement in the interval t equals 0.7 to 1.4. Part B asks for distance, which is, we'll call that S prime integral t equal to 0.7 to 1.4, the absolute value of v dt. Speed multiplied by time. So the only thing that will change is replace negative 0.4305 with plus 0.4305, and same goes for minus 1.1098 with plus 1.1098. Make sure it's captured on the video. This is a separate problem. So we start here. Displacement is the vector velocity multiplied by time. That is, the vector equivalent would be S bar is integral TA to TB or T1 to T2 V dt. The distance, of course, S equal to integral T1 to T2 speed dt. Yes.
This equation, you're changing to take the absolute value. Is it just that f of x values are all positive?
Yes. Only magnitude, only positive values. That is, a function can have both negative and positive value. You just take the magnitude without the sign. You should know this. I won't be providing this. That should be something on your sheet.
Regular trapezoidal areas, each trapezoid.
That is what this is.
Yeah, but do we have to show it like this in order to get credit?
You have to show which formula you're using.
To do the area of each trapezoid?
That's what this is. So you can do the long way or you can do this. Integration is by far the easiest thing you will see on the test. It will take you 5 minutes and you can score 20 points. Gauss Seidel will also be easy, but it will take you time. Integration will take hardly 5 to 10 minutes. Okay. Okay, moving on. So problem 3 and 4 will share the same data. Even on the test, it's going to be like that. For the same particle, I'm asking compute the acceleration between 0.7 and 0.4. For practice, I'm telling you do first order backward differencing and then do a second order backward differencing. in the exam, you will be told which one to use. And you will be given a table of differentiation formulas. You will have to know how to read that table. First order, second order, forward, backward, central, everything will be more information than needed will be given. You should know how to pick it. Okay. So we are asked for acceleration. It doesn't say magnitude of the acceleration, it just says acceleration. So essentially we have been asked to calculate what is A equals dv dt. With considering B as a vector, not as a scalar, as a vector. Okay. Okay, so you're asked to calculate the acceleration at several time points. So this is like 8 calculations that you need to do. And how would you do that? So if I choose the if I choose the first order backward differencing scheme, 1 second. Oh, I have the data here. Awesome. So acceleration of time, I need to do between 0.7 and 1.4. So I'm going to highlight that. At 0.7, I need to do Vi minus Vi minus 1 divided by delta t, which happens to be constant, 0.7 minus 0.6. And I have to do this for 8 more times. So you might have to do this at least 3 or 4 times. I'll make sure you don't do it like 8 or 20 times. Okay. But you definitely have to do 2 things. One is you have to pick out a formula from a long list of other differencing formulas. Second is implement the calculation correctly. So this is acceleration using first order backward differencing scheme. Okay. So can I also do this same calculation, acceleration, instead of first order, let me do second order backward differencing. You can pick out the formula, but what's the difference between first order and second order conceptually? Yes. How far in the past you have to look back, right? So for first order, you just look back 1 step. For second order, you have to look back 2 steps. So the formula goes as Vi minus 2 times Vi minus 1 plus Vi minus 2 divided by the delta t between the first and last step. Okay. Don't worry too much about the interpretation. If you are asked to do a second order formula, pick the correct formula. That's what I'm really looking for. Are you able to pick out formula from a list? Pick it out, write it explicitly. This is the formula I am using for my calculation. Do the calculation, make sure it's not wrong, but don't worry about the numbers. Don't try to interpret, don't try to think about the numbers, just do the calculation. Okay. So if we do second order formula, we are getting a different value. Let's not go into thinking about what it means and so on. I just want you to be able to calculate differences. Okay. Yes. Sure. Actually, I'll write it out on the board. Actually, let me just make sure that I picked out the correct formula. So here is the book. Please don't make me do this. Does anyone have figure 23 from the book? If you have it handy, can you look? All right. So we want to go to chapter 23, which I don't know what's the page number. 655. Okay, figure 23. We're almost there. All right, this is the table that will be given to you. Okay, figure 23.1 for forward, figure 23.2 for backward, and figure 23.3 for central. Now, this is the time domain problem. If I see you doing a forward difference or a central difference, 0. After that, we won't even bother to read your solution, because when you calculate time derivatives, the future cannot influence the past. I'm sorry, the future cannot influence the current. It has to be backward. Okay. So figure 23.2, if it's a time domain problem, which most likely it will be, and the first order formula is right here, which is what we used. The second order formula, oh, I made a mistake. It's 4 times and minus 3 times. So let me fix that. 4 times and 3 times. Let me make sure and go back and do this here. So this is minus, sorry, this is forward, sorry. Backward, 3 minus 4 plus 1. That's what I got, 3 minus 4 plus 1. Three minus 4 plus 1. Okay. So 3. Is this hard? Okay. 3 minus 4 plus 1. There we go.
What was that?
Denominator is 2 times delta t. You can either do 2 times 0.1, or I did 0.7 minus 0.5, which gave me the same thing. Okay, so we'll just stick to what's on the page. So that is 2 times delta t, which is still 0.7 minus 0.6. So there we go. We get another set of calculations which are quite similar. So the difference is essentially because I made a mistake, but the skill that we are looking for is from this table of formulas, are you picking the correct type of differencing backward for time domain? Are you picking the correct first order or second order formula as it is asked, which is either the first line or second line? You're going to get exactly this page. So it actually becomes a literacy test. Can you read? Can you read this? Can you read this and copy this? So the literacy test. This one, 2 delta t. It's in the denominator.
Yeah, you're dividing the two, but
No, I'm dividing this thing in the parenthesis by 2, and I'm also divide the same thing by, if it's confusing, I'll write it like this. 2 times same thing. So 2 delta t. Okay. All right, good. So you should be able to read this table. Okay, got it? Yes. Third order. Well, we can derive third order, but if you can derive and read second order, I trust you will be able to do that also. Doesn't, yeah.
On the test, are you gonna be expecting us to also do differencing?
No, because we are doing only time domain problems. To do space domain problems, you need to do what is called as steady state problems, which we didn't see. We only saw RK methods, which are meant for time domain problems. That's actually a good question. You cannot use RK4 or Euler or those methods for spatial problems. They are meant only for time domain problems. Okay. All right, good. So I think my file is not responding. We have 30 minutes and we'll do problem 5. So we have done up to differentiation, and problem 3 and 4 will share the same data. I told you that. It could be distance, displacement, acceleration, or sorry, distance, velocity, acceleration. It could be charge, current, and rate of current or inductance. It could be, there was one more quantity. Anyway. Okay, problem 5. This is what we need to solve. System of two ODEs for x and y, which are coupled to each other and are both functions of time. Use a time step of 0.1 and calculate the solution for 0.1 and 0.2 seconds. Do your work separately, but fill out this table. So this is the first thing we'll see, and then we'll check your steps. It says practice with all 3 methods. Whatever method I do ask, I'll provide the expression in the exam. So that it's RK4 or other 2, So for now, for keeping it short, let's do Euler, okay? You should practice RK2 or RK4 as well. It's quite likely it may be asked. Okay. So iteration number, time, xi, yi. We are doing Euler method for simplicity. Euler, but also practice RK2 and RK4. Euler method is if dx over dt equal to f of t comma x, then xi plus 1 is xi plus delta t times f of ti comma xi. So initial conditions, x is 1, or when time is 0, x is 1 and y is 0.5 or half. So we want to start with, this is initial condition, start with iteration 1. So iteration 1, xi plus 1 or x1 is x0 plus delta t being 0.1 times. You have two equations, okay? So we'll call dx over dt as f of x and dy over dt. We'll call it g of t comma x comma y. This is f of t comma x comma y. So you also have to update y. Yi plus 1 is yi plus delta t times g of ti comma xi comma yi. I will only provide the general template. That is, I'll provide something like dx over dt equal to f of t comma x, which means xi plus 1 is xi plus delta t times f of ti comma xi. I'll only provide this. You have to understand or make the leap that they have to be solved simultaneously. So for iteration 1, x1 equal to x0 plus delta t being 0.1 and function f is minus xy time, that is minus what is x1, what is y 0.5, and what is time? Time happens to be 0. So this is 1 plus this. So this is simply 1. Y1 is 0.5 plus 0.1 times. You have e power minus x multiplied by y. That's the cursor. Okay. So this is minus e power minus x, x being 1 times y being 0.5. So can you compute this and tell me?
One TI.
Yeah, x is 1. This negative comes from the function. This 1 is x. This 0.5 is y. This 0 is time.
Oh, you were.
Xy x minus xy t minus e power minus x times y. Yes.
Can you tell me what that thing that's a far right is? What you were doing?
So equal to 1.
Okay.
Oh, I'll rewrite it. So what I told was, if we are saying use Euler method, I will only provide this information. Euler method is xi plus 1 equal to xi plus delta t times f of ti comma xi. Only this will be provided. Whether it's a second order ODE or two first order ODEs coupled together like this, you have to write it together like here and say we are simultaneously updating the solution. If we don't see simultaneous, if you just first do x and then come to y and there is a coupling there, done, 0 credit. If you don't do the simultaneous thing, 0 credit. I should put that in writing. If missing, 0. You'll thank me later when you get your PhD. Or maybe when you get a job. Okay, can we get y1? Yes.
Why is G a function of T as well? Like,
It could be. In general, it could be a function of txy. It could be a function of txy. So I'm going to create an Excel sheet. You could do the hand calculation and tell me. Minus 1 into, what is that function? Minus xyt. And y is y minus this times minus 1 times exponent of minus x times y. or numerical solution. In the problem, you're just asked to do 0.1 and 0.2, okay? And if I couple that with RK4, that's like 4 plus 4 plus 4 plus 4, that's 16 calculations. If I couple that with RK2, that's like 2 plus 2 plus 2 plus 2, that's 8 calculations. So I'll try to optimize the number of calculations that you need to do to keep it around 6 to 10, okay? Not more than that. Right, but you will be asked to compute at least one full iteration. That's for sure. Okay, I think I should stop the screen share so that the camera can see this. Okay, we have 20 minutes. Are there any questions? I had one last thing to say about the course. Yes, questions? So this course, we have spent a semester learning a lot of methods. Of course, the exam is there, you'll study for it, but after you forget everything that you studied this semester, what do I want you to still retain or kind of remember, into your careers and stuff? So in module 1, we saw statistics. At this point, what do you recall? What can you still retain, knowing that you don't have to take an exam on statistics again? Here are the things that you will use or you will need as you become an engineer. Hopefully, stay as an engineer, not become a financial professional or a salesperson, somebody who does engineering. Okay, hopefully stay there. So you would need to compute confidence intervals. That's something you'll have to do or remember, also known as uncertainty, outlier detection, and hypothesis testing. When everything is said and done, these 3 important things, if you remember or know, it means you also remember the underlying things, or you are at least aware of the underlying. We did saw algebraic equations. Having to do this, pretty regularly, I would say if you remember 2 methods, Newton-Raphson and secant method, you're good to go. Any algebraic equation that you will ever encounter can be solved between these 2 formulas. That's all you need to know. Okay. The third module we saw linear equations. What we saw is Gauss-Seidel, which is pretty useful for automation. Okay. There are also matrix inversion methods. There is Cramer's rule that we didn't see, and then there is also tridiagonal matrix algorithms. All these are not very complicated, but you might need them. But the best method is for brute force automation. Gauss-Seidel is like, you don't have to be very skilled to use it. You can just implement. Okay. So that's module 1, 2, and 3. What's module 4? Curve fitting. There we saw least squares. We saw the trial function approach. You need to know how to set up 3 equations for C1, C2, C3, or even more, C4, Cn, to get n parameter fits. This is the real skill that you will need to use or need to retain, hopefully, after everything it clears out. Numerical integration. There are more sophisticated methods, but if you understand in principle that an integral a to b of f of x dx is approximately equal to half delta x times f of a plus 2 times the intermediate values, plus f of b. If you understand this in principle, on any day, you can study the next complicated method and implement it. You don't have to remember all of them. I certainly don't. I start from here and I can quickly work my way towards more sophisticated algorithms. Numerical differentiation. I mean, for all time domain problems, okay, we approximate this as xi minus 1 delta t equal to f of ti comma xi. From here on, you can solve for xi and move forward. Okay. You can also, not you can also, when you do this, RK4 is the best method out there. There are 5th order, 7th order RK4 methods. They involve more effort for the same gain. RK4 is kind of the sweet spot. If there is one thing that you remember away from this whole course, it's RK4. You can solve pretty much any time domain problem using RK4. Okay. The last thing is coupled ODEs, which could be in two flavors. One is you have a nth order differential equation, which becomes n first order equations, or you could have dx1 over dt equal to dx2 over dt equal to, and you can have n equations which are also the same. You should know how to do them simultaneously. So when you have forgotten everything you have learned this semester, this is, if this still, some of this still retains, this is what you really need on the field to actually do calculations. Okay. Okay, questions. So please do the mock exam, upload it, 3 points, easy takings. Do your project. Please do it before the deadline, which is midnight on study day. Come prepared for the exam, do the practice problems, do the mock exam. Last thing, I gave 3 points for you to do the course evaluations. Please do that. It's a large class. I would like to see some of the things I tried, how they came across. I want to know what you think. So please do that. It's been a fun semester for me. Not sure about you. Thank you. Bye. Yeah.
Are you gonna talk about video?
Oh, yeah. Please sit down. So I told you there is a video assignment for your project. Question was how many credits? Like, what's the offering? I will give you, if the video is exemplary, I will give you half a standard deviation. If standard deviation comes out to be 4 points, you will get 2 points bonus for doing an exemplary submission. If it's a decent submission, which is okay, you will get quarter standard deviation. If it's a like a very how should I say this? Not a very diligent effort, you get 0 because it's a bonus exercise. If you don't meet certain standard, I don't have to reward you. So a good submission will get you half a quarter standard deviation. Exemplary submission will get you half a standard deviation. So if the average comes out to be 80 and standard deviation is 4 and you are stuck at 83, it will help you get to the next bracket. Okay, so think about it. Yes.
Does the video have to be done as a group or is it individual? Like everyone has to record their own?
One video per one sub. You are doing everything together. Your project is a group assignment, so it has to, in fact, it has to have all the members. If it's done by one person, I don't know whether the others did something or not. So it has to be a group presentation in which all members contribute fairly equally. Okay. So if you're thinking I'll do something and get something, there are only 3 scores: 0, quarter standard deviation, and half standard deviation. So please don't do something that's that you know is not good. Make a genuine effort, and I'll reward you for that. Okay. Yes.
Will you be in your office and study day?
Not sure right now. I'll make an announcement about that. I don't know my schedule yet. Next week is going to be busy for some other reason, but I'll let you know.
We have issues or problems currently, and, can you just email you?
So with regard to mock exam, I think I went through a pretty detailed solution. I'm not going to take any questions on that. I want you to try and upload, and then on Sunday, I'll release my solution. Other related questions, or you're practicing something else and you have some conceptual doubts, you're welcome to contact me. I'll be here tomorrow. I won't be here Monday. I'll be here Tuesday, Wednesday, Thursday. I'm not sure about my schedule, but of course, you don't need me on Wednesday. Your exam is already over. Okay? Yes?
The next exam is only the topics covered on the mock exam, right?
Yes, only from here, that is module 2, 3, 4, 5, 6. Yeah. This is all purely for knowledge. If you are post knowledge, this is not for you. Thank you.